大家好，
and welcome to Context Free, where we talk about programming languages. Today, I want to talk about the new records feature of C# 9, which is a way to express value-oriented types that are also reference-based. Similar features have also been proposed for JavaScript and Java, also under the name records, and Python in recent versions has introduced similar features under the name of data classes. We'll also take a look at Rust and see how it compares with these other languages. But the primary focus today is going to be on these languages that are traditionally considered to be object-oriented and how the introduction of these value-oriented classes that are primarily focused even on immutable data is part of the trend toward functional programming that we've seen in recent years. So let's take a look at C# here. We have a class employee with name and hire date properties. There's also a simple method here for years employed that just looks at the year, meaning are they going to have a 5, 10, or 20-year anniversary this year? And our top-level code, also a C# 9 feature, includes the creation of one employee object for Alice, who is hired on January 1st, 2000, and we print the object and the years employed. This top-level code in C# is somewhat different than top-level code in other languages that look like this. We'll have to explore that in another video, perhaps some follow-up to the Hello World video I did before. For now, I'm having fun exploring it. So to start with, let's run this and see what we get. We print as just employee, and we see there's been 20 years. Now to get the idea of what we mean by value-oriented, let's make a couple new employee objects. We'll say Alice 2 and 3. And we'll say Alice 2 is a different employee who was hired in 2010. But Alice 3 is just a different object instance for the same original Alice. Now, of course, this isn't a fantastic schema here because it's easy to imagine that a unique name, hire date pair doesn't necessarily mean a unique person. But right now, I'm not focused on schema design. I'm just focused on values. And for our current purposes, the employee object is defined in terms of the unique values of the properties. So let's see if these objects are equal. Compare to Alice 2 and Alice 3. Let's run it. And we see that it's false in both cases, because by default, the operator double equals is going to compare pointers for classes, which are reference types. But if we change this to record, it remains a reference type, but automatically fills in a number of methods to define equality and string representation. So if we run it again now, we'll see that Alice and Alice 3 are equal to each other because they contain the same values. And note that in all this discussion, there's a different kind of idea of value than what structs are in C#. In C#, structs are value types in the sense that they're not reference types. That is, they're expanded in place, and when you pass them around, they pass by shallow copy. Records are reference types like classes, but have these certain amount of value semantics associated. Again, such as equality and built into string. In olden days before C# 9 and records, I could have overridden equals and the double equals operator. This built-in code snippet in VS Code C# extension gets me part of the way there. We can see the amount of pain involved in doing these kinds of things manually, and some effort to go to fulfill the guidelines required. Now also that hash code often goes with equals, because hash code usually is some kind of non-unique representation of the value of an object. Go ahead and remove that. And let's see if we can use these employees as dictionary keys. Let's get colors for each employee, their favorite colors, for example, what color of mug we should get them for their 20th anniversary. Dictionary from employee to string. So we'll go from Alice to Aqua. Then print out the color for Alice. We run it, and we get Aqua. What happens if we put Alice 3 here instead? Distinct object, but same value. We still get Aqua out. But note that my values here are mutable. So let's change the original Alice. 2002, 22. Now, after I used Alice as the key, and this is a reference type, I'm going to modify the reference that's being used as the key. If I run it, I see key not found exception. So the recommendation actually for record types in C# 9 is don't let them be mutable. They let you make them mutable. That's not the recommendation. We can use init accessors rather than setters just by switching to init here. If we try compiling this now, I get init only property, which means we can't modify it. We can only initialize. So let's try it again after we've taken this away, and we're back to working again. And we don't get surprised by keys changing behind our backs. In addition, records allow a new feature to build objects based on other previously existing objects. So instead of saying a new employee, we can say the same as Alice with some changes, which creates a new object based on a previous one. So I could create, for example, Alice with a new hire date, or Alice 2 with the original hire date, and it should give us what we started with. And it does. Finally, worth pointing out that we can also make subclasses for our records in C#. So we can say record detail employee extends employee with, for example, their favorite color again. And another thing we can do is make a positional constructor for positional records, which feel a lot like tuples at this point. So we can take these out and put them in here. Which allows us to construct Alice instead as a new employee with positional values, which might also remind us of the positional versus named field initialization in C and C++ structs. I can try running this, and we see a fail here though. And that's the complaint of not having a default no-arg constructor in this situation. So let's hide this again and see it work. But we find ourselves also at odds with this form of construction. And again, because we're looking for a no-arg constructor. This initialization happens after the constructor is called. So we can go down here and give default values. And we're good again. However, if you've heard from me before, I'm not a big fan of positional arguments when constructing objects, but I'll leave them here now for exploration purposes. We have another issue to watch out for as well. Say we never gave a name, but we wanted to require it. Nothing here is going to make that happen. And there's actually no feature in C# 9 to require values for our properties, except in the case of explicit constructors. Had I not provided default values for these, I would need some kind of validation method instead and require to call it manually if I want to verify against it, as one possible solution. Now we still haven't seen everything about C# 9 records, but we've gotten a pretty good feel. Let's move on to Java and the preview records there. So this is what things look like in the Java records preview. A lot like the positional record from C#. Although subclassing isn't allowed for records, and all of these record classes extend java.lang.record. If I want to make a longer record that contains more fields directly, but have options for my construction, I might either have a variety of constructors overloaded, or I might want to use a builder pattern. We can put in custom methods, and furthermore, we can also sort of extend the constructor. Notice the lack of parentheses here, and this runs after the main constructor gets called, which allows us to automate this validation that wasn't going to work as easily in C#. On the other hand, there's no named field initialization, so in my mind there are pros and cons. We can construct our objects And I may have missed it, but I found no with syntax like what we had in C# to create derivative objects. Instead, I just create new objects from scratch. But interestingly, this local date object in the Java standard library has methods with the same kind of with feel. Maybe in a different universe, there were records first and a with capability such that this method never needed to exist. And let's make sure to run this to know that it works. We see our automatic to strings. We see that Alice and Alice3 have the same hash codes, which are different from Alice2. And we see that Alice and Alice3 are equal to each other, none of which I implemented manually. As far as ordering comparisons, they do not come automatically with the Java preview records, nor with C#9 records. Meanwhile, having seen Java, let's take a quick look at Python as well. Python data classes came out in version 3.7, and to use them we decorate another class, and we can provide arguments to this decorator. In this case, I'm saying I want shallow immutability, and I want to define ordering comparison. We can define our fields, and we have an automatically called post-init method to do our assertions or whatever else, and we can define other custom methods as well. Subclassing also works. We could construct an employee with named fields or positional, where the order in the class is what matters, which will likely remind us again of structs in C or C++. We get nice stringification, hash out of the box if we choose frozen, or override that we want hash without being frozen. And we get equality comparison, and if requested, ordering as well. Let's try it out. And we see here the same hash codes for Alice and Alice3. We get that Alice equals Alice3, and that Alice is less than Alice2. And that's because the higher date for Alice is earlier than for Alice2. And while the Zen of Python says there should be only one way to do something, we find that often in practice there are a number of options available in Python. So for example, instead of a data class, we could make it a named tuple, available inside of typing. However, instead of this top-level replace function, which acts like our with from C#, we'll use a method of underscore replace instead. And in both cases, you can see how there's an attempt to avoid conflicting with the namespace of the fields inside of our class. Let's run this and see what we get. It's quite the same as before, only different kind of calculation for the hash code. I'm not going to demo it here, but the subclass no longer works as expected. And finally, there's yet another option, which is a typed dictionary. This no longer allows custom methods because all we'll get is a dictionary out. And being a dictionary, we need to use dictionary operations, which could include a dictionary splat, or the new dictionary union operator from Python 3.9, or other alternatives as well. Furthermore, hash and ordering isn't defined for dictionaries in Python, partially because the dictionaries are mutable, and if you can change keys, as we saw before, there's a risk of causing trouble. But just to prove this works, well, it may have worked if I get rid of the subclass as well. Now to prove it works, we can see our dictionaries here, and that Alice equals Alice3 in terms of value. And I find this a little bit interesting to look at, because ordinary classes in Python usually use a dictionary for their contents. But there's a dichotomy between explicit top-level dictionaries, the dictionary hiding inside of classes otherwise, where they have a lot in common, but you interact with them differently, and that has its pros and cons. And as I said, before we're done, let's take a quick look at Rust as well, which isn't an object-oriented language, although it has some features that feel like it sometimes. And it might have a little more in common with C or C++ way of thinking about things. So for example, we'll use structs rather than having some kind of class-struct dichotomy, like what we had in C#. In Rust, like in C or C++, by default they're always going to be expanded. But I can ask for toString, or hash calculations, or equality, or ordering through the derive macros, which feel a little bit like the data class options we had in Python. And these will automatically implement traits to give us these capabilities, as might be possible depending on the fields inside of our struct. Also worth pointing out that record hasn't traditionally meant some kind of value-oriented class. I first ran across record in Pascal long ago after having started learning C first, where record in Pascal is a lot like struct in C. But in any case, we can create an employee instance and create derivative instances with a bit of this splat feel, like what we had in Python. Then we can print things out, calculate hash codes, and compare things. So let's run it. And again, we see Alice and Alice3 have the same hash code, and they're equal to each other, and we can get ordering just like what we had in Python. All of these instances are also immutable because that's a default in Rust, or you might call it deep const. We also can make mutable instances just by saying mute here. But again, it's not the type that's mutable or not, it's how we use it, at least in common cases. So before we finish, let's look at the Stage 2 record and tuple proposal for ECMAScript. This isn't quite available in Babel yet, but there is an online playground to try it out. Records look like ordinary objects, but they have this hash symbol in front. And records are types that define their identity in terms of their value, just like primitives in JavaScript like numbers or strings. So for example, Alice and Alice3 are triple equal with each other. It doesn't matter if they're different objects in memory, because their identity is their value, even though Alice3 is defined from a splat of Alice2 with a new higher year. That's equivalent to the same higher year as Alice. So we see that they are triple equal to each other. And the other interesting thing about this proposal for ECMAScript is that all the contents of a record also have to be value types. So a record or a tuple in this proposal is always deep const, which is something we don't see in Java, C#, or Python. Meanwhile, I hope this has been fun. Maybe we can look at this kind of topic again in the future, such as if Java or JavaScript get records into their actual release. Or maybe we could also look again at how these things work for dictionaries or hash maps across these languages instead. If you like the video, be sure to subscribe.
我们下次再见。